Hello family, good morning. You are welcome to my YouTube channel, the Explicit Tutorials, and happy new month. Today marks the first day of the month of May. Alright, so in today's video we are discussing gastrulation. Please, as you are watching this video, endeavor to subscribe, like, share and comment. In today's video, of course, we shall be discussing gastrulation. Alright, gastrulation is from the word gastrula. Alright, gastrula could be 2 or 3 layered embryo. Alright, I can say that gastrula is a 2 or 3 layered embryo. In other words, I'll say it is a multi-layered embryo. Now, the word gastrula, we also have what is called blastula. Now, fertilization, which involves the fusion of the male and female sex cell, called the sperm and egg, respectively, to form zygote. All these processes occur in the fallopian tube of the female. As soon as the zygote is formed via fertilization, what happens? Zygote. Because zygote is formed through fertilization. Now, the zygote undergoes cleavage. It undergoes cleavage to produce what? Blastula. Now, if the gastrula is 2 or 3 layered embryo, it means that the blastula is what? A single layered embryo. Which is to say that gastrulation is a phenomenon characterized by the transformation of a single layered embryo called blastula into a multi-layered embryo called gastrula. Alright, the process whereby a single layered embryo called blastula is converted to a multi-layered embryo called gastrula is called what? Gastrulation. Alright, now the purpose of gastrulation is to form 3 primary germ layers. Alright, you call them primary germ layers. Alright, primary germ layers. Now, these layers, they are actually triploblastic 3 germ layers, which are the ectoderms, okay? Ectoderm, mesoderm, and what? Endoderm. So, in case it comes out, what is gastrulation? You say gastrulation is a phenomenon characterized by the transformation of a single layered embryo called blastula to a multi-layered embryo called what? Gastrula, to form a primary germ, or to form primary germ layers, which are the ectoderms, the mesoderm, and what? The endoderm. That is a complete definition of what gastrulation is. And now, once these layers are produced, these different layers, they develop into different entities. For example, now the ectoderm, which is the outermost layer, this ectoderm develops into skin and nervous system. The ectoderm develops into what? Skin, or the ectoderm forms, please, I'm busy. The ectoderm forms the skin and what? Nervous system. You now have the mesoderm. The mesoderm, which is the middle layer of the embryo, forms the muscles, skeletal system, and what? Circulatory system. The ectoderm so produced gives rise to skin and nervous system. The mesoderm forms the muscles, skeletal system, and what? Circulatory system. While the endoderm gives rise to respiratory tracts and digestive tracts. In conclusion, muscles, skeletal system, and circulatory system are derived from the mesoderm. Nervous system, skin are derived from the ectoderm. The endoderm gives rise to the respiratory tract or digestive tract or the gastrointestinal tract. Please, this is just introductory part of this topic, gastrulation. Now, please, the primary aim, just as I stated, that the purpose of gastrulation is to form 3 germ layers. In other words, the purpose of gastrulation is to bring to the interior parts of the embryo, that is an area of what? Blastoderm. Now, this area of blastoderm in the embryo, all right, develops into different organs, all right, and into different tissues. You know that gastrulation at the end produces what? Organs, tissues, and so on and so forth, systems. Now, the blastoderm, which is the interior part of the embryo, develops into, of course, I've listed them, bone, respiratory system, circulatory system, whatever. All right, so please take note of that. Gastrulation is a phenomenon characterized by the transformation of a single-layered embryo called blastula into a multi-layered embryo called blastula, all right, to form primary germ layers, which are the ectoderm, the mesoderm, and the endoderm. Full stop. You are not stopping there. You further stating by saying that the ectoderm forms the nervous system and the skin, the mesoderm forms the muscle, skeletal system, and circulatory system, while the endoderm forms the respiratory tracts and what? Digestive tract or the gastrointestinal tract. That is all about what? Gastrulation. Now in bronchiostoma or bronchiostomata is actually a type of, it's a subphylum, okay? It's a subphylum. Now, in bronchiostoma, otherwise called Amphioxus, and amphibians, in amphibians, of course, these are the frogs and toads. Good. The gastrulation process that occurs in bronchiostoma, otherwise called Amphioxus, and amphibians, frogs and toads, it is characterized by the inward folding. Look, this is the word. The inward folding or bending. It is the inward folding or bending of the cells of the vegetal pole. Let me not use this word, vegetal pole, sorry. Let me not use that word for now. Because the reason is that in bronchiostoma, alright, the vegetal pole is able to invaginate, that is, bend inward. But in amphibians, that is never the case. That is because the blastula of the amphibians, they are highly compacted with lots of yolks. So they are not able to bend inward. Therefore, the process begins with the cells found in the marginal zone. Now we'll get to that. What I'm trying to say is, I will not use the word vegetal pole. All right. Gastrulation in bronchiostomata and amphibian is actually the inward folding or bending of the cells of the blastoderm. Yeah, let me use this word, blastoderm. I don't want to use the word vegetal pole, because vegetal pole is peculiar to just the branchiostoma and never the word the amphibians. Okay, now please, gastrulation in these two striking examples here occurs in the presence of three processes, which are invagination. If I don't call it invagination, all right, I also call it caving. Two, you have what is called involution, and three, expansion. So they may ask, gastrulation in branchiostoma and amphibians occurs in three phases, or gastrulation in branchiostoma and amphibians occurs in different or three different processes discussed. So the different three processes are actually the invagination, or that is otherwise called caving. You now have involution and what? Expansion. So these are the three processes that must occur in gastrulation in branchiostoma and what? Amphibians. So let us now look at, we said that gastrulation, the end or the purpose of gastrulation is to form three germ layers, which are the ectoderm, the mesoderm, or the endoderm. Now let's check what happens during gastrulation. Like diagrammatically, let me use an illustration to explain. Now, I said something that the blastula is, okay, I said the blastula is actually single layered. The blastula is single layered, of course, nothing like this around it. All right, so let me do an illustration of gastrulation for a better understanding. What I have here is a blastula. All right, what I have here is what? A blastula. Now this region of the blastula is actually called the blastocoil. You can call the blastocoil a body cavity that is filled with fluid. You therefore say that it is a fluid filled cavity. Okay, sorry, L. At first, we said that gastrulation involves the process whereby a single layered blastula is converted into what? Multi-layered blastula. At this point, nothing has occurred, nothing, it's just there. Now the inner part of this blastula is what? The blastocoil, okay? The blastocoil is called body cavity. You therefore say it is what? A fluid filled body cavity. All right, that is what, cavity, sorry. Now, then after this part, okay, blastula, let me use an arrow now. Nothing has happened, nothing. Then after this phase, which is a single layered embryo, what happens? There's what we call invagination. Invagination, I'm going to be explaining by using all these terms. During invagination, all right, during invagination, the vegetal pole of the blastula, which is, this is the animal pole, don't forget, this is the animal pole, this is the vegetal pole, and the left hand side is actually the ventral side, and the right hand side is called what? The dorsal side. Now during invagination, what happens? The cells that make up that is the vegetal pole push inwards. This is what you are going to be having. It will push inwards. This marker is giving me issues, man. So now you have this. You now also have this. Now, the vegetal pole of this guy has pushed inward. You say it has what? Invaginated. Now, as soon as it invaginates, it forms a hollow. This hollow formed by the invagination of the blastula is actually called, let me drop this marker please, it's actually called a kenteron. The hollow or the pocket-like tube or structure formed by the invagination of the blastula is called what? A kenteron. Now, looking at what we have here, okay, you see the entrance, the exterior part of the acheron, that is the opening found in the acheron. We call it what? The blastopore. All right. Now, as time goes on, I'm going to be telling you what the blastopore develops into. The blastopore develops into the mouth, called prostomes, like protostomes. Yeah, protostomes. When the blastopore develops to the mouth, you call the mouth protostomes. When it develops to the anus, you call it what? Deuterostomes. All right, deuterostomes. And deuterostomes are actually, we have 3 striking examples of deuterostomes. All right. Now, please permit me to say this. Protostomes is the mouth that the blastula develops into, while the deuterostome is actually the anus that's the blastopore develops into. Please, blastopore. Now, we have different examples of deuterostomes. All right, deuterostomes. On a better note, is that deuterostomes are actually organisms whose blastopore develop into what? Protostomes and what? Anus. Now, we have 3 striking examples of deuterostomes. All right, we have the phylum Chordata. Phylum Chordata, of course, that is where you have the vertebrates. All right, vertebrates. You also have phylum Echinodermata, where you have the sea stars, the sea cucumber, the sea urchins, All of these are echinoderms. They have spiny skin. And they have high level of what? Regeneration. Now, the last one is the hemichordata. That is where you have the ascon worm. All right. So please, these are the 3 examples of what? Deuterostomes. Now, I said as soon as the vegetal pole of the blastula invaginates, it will produce that is a hollow or pocket-like structure called what? That is a kenteron. Exteriorly to the acheteron, you have the blastopore. Now, as soon as you have this, all right, of course, you now have, there's the endoderm. This is the endoderm, and this is the ectoderm. All right, and this parts you have here is called the dorsal lip. The dorsal lip. All right, I told that the right hand side is the dorsal side, while the left hand side is called what? The ventral side. Now this other part is called what? The ventral lip. The ventral lip. Take note of that. It is very, very important. Excuse me. So, of course, this outermost part is called the cortex. You will observe that as soon as this organism, as soon as this blastula invaginates rather, it does not form mesoderm. You only have ectoderm and what? Endoderm. Now, from here, that is from this very structure, it develops into three-layered embryo. Let me make the article very long. Three-layered embryo. So at this point, you now have the three germ layers. Of course, the mesoderm is actually found between the ectoderm and the endoderm. So, I now have this. Let me make it big a bit. Sorry, hold on. Let me increase the size. Yeah, so I have sometimes is all right. This is what you are going to see complete. Now, this parts of the blastula, this is a well labeled blastula, but the complete one you now have, of course, this is the outermost layer. I told you it is cortex. Here you have the ectoderm. All right, here you have the endoderm. Then on the roof of the archeteron, that is where you have the mesoderm. You have the mesoderm and of course archeteron. Here of course is the blastopore, and here is the ventral lip, and here is what? So I would have done this before this very one. This is what? The dorsal lip. Right, this is the animal pole, very important, and what? This is the ventral pole. What I've just done is the life cycle of what? Gastrulation. You can see now that the mesoderm is actually found between the ectoderm and what? The endoderm. All right. This is the endoderm. Look at the line here. This is a line. All right, it's found between the ectoderm and what? The endoderm. Mesoderm is just found at the roof of what? The archeteron. So this is the life cycle of what? Gastrulation. And at the roof of the archeteron, I said, lies the what? The mesoderm. Take note of that. Now the process whereby the vegetal pole bends are used in vagination to explain these first parts. All right, the process whereby there's a formation of new germ layer, that is the process whereby the cells of the blastoderm folds inside. It folds inside to form what? A new cell layer. I don't know, can I rub off this one? Or let me just write it somewhere. All right, during involution, all right, there's inward folding or migration or bending of cells into the interior region of the embryo. Right, it is the bending of that is the vegetal pole towards the inside. The word interior means within what? The embryo. Now as soon as it is pushed within, you have exteriorly the blastopore. Of course, actually the entrance and is found outside. That is from the exterior to the what? The interior. Okay, that is what you have it to be what? In involution, like I stated before, right? Involution. All right, and at the end of involution, there's formation of what? New cell layer or structure in involution. All right, now after involution, you now have what? Expansion. Now, okay, actually before expansion, though you don't have what I'm about to say on the material, you have extension. When the cells that make up the embryo elongate, the elongation of the cells of the blastula, we call it what? Extension. But when the embryo as a multi-layered structure now increases in size, you call it what? Expansion. Expansion is a phenomenon characterized by the increase in size of the multi-layered embryo. As soon as it increases in size, there's what? A rapid proliferation and division of the cells found in the embryo. I'll recap. Extension is when the cells that make up the embryo elongates, but expansion is when the embryo increases in size, followed by the rapid what? Proliferation. All right, the rapid proliferation and division of the cells that are found inside the embryo. So, which means that proliferation and division occurs during expansion. It does not occur in invagination. It does not occur in involution. The difference between involution and invagination is that invagination leads to the production of what? A new cell layer, but involution results to the formation of a new cell layer, all right? But invagination results to the formation of a pocket hollow structure called what? A catheteron, or you call it pouch, all right? All right, so take note of that. It is very important. So I would say this is a life cycle of what? Gastrulation. This is a life cycle of gastrulation. Now, why is expansion very significant? It is very important because it is important for the proliferation and division of the cells found in the embryo. And secondly, it provides the proper positioning and movements of the cells for subsequent what? Processes, just as you have organogenesis, all right? The process by the ectoderm, the mesoderm, and the endoderm form organs. You call that what? Organogenesis. Before organogenesis, the embryo has to expand, and that expansion is actually very important for organogenesis to occur. So I've explained the three terms associated with gastrulation: invagination, involution, and what? Expansion. You also have extension, which means what? The process whereby the cells that make up the blastula or the single layered embryo elongates. All right. Take note of that. So please, in case we are asked, because I'm also included, we are together, we are one family. In case we are asked to give a well-labeled structure of a typical gastrula, please, it is very important you do this. You see that this one is not complete. It is what? Incomplete. All right. See, if you are given this is what you have on the material. In the material, you don't have the mesoderm. You only have the ectoderm and the endoderm. Okay. You call this what? Two-layered gastrula. But this one is complete. You call it what? Three-layered gastrula. And on the material, the lecturer actually used this when he explained gastrulation in Amphioxus or branchiostoma. Right. This is, in case we are asked to explain the processes that take place in the gastrulation of Amphioxus. After saying everything you want to say, it is very important you conclude by putting down a diagram of what you've said so far, and this is what you are expected to put down. Okay, I believe that is understood. All right, so the next one is going to be somehow I've simultaneously explained gastrulation in Amphioxus. Yeah, I've explained gastrulation in Amphioxus. Now, if you should give the lecturer what this life cycle under the gastrulation of Amphioxus, so not amphibian, no. In Amphioxus, you can do this. Very, very important. Now, I told you that in amphibian, don't worry, in our next video, I'll upload video on what? Gastrulation in amphibian, alright? But now, let me do a brief explanation of gastrulation in Amphioxus. I think I've already explained it, okay? Can I rub it off? Let me rub off this place, please. So please, it is very important we understand every point here, because I'm also included. And don't worry, the Lord will make us to remember all that we have read for examination. His grace is sufficient for us to actually comprehend and put to play all that we have read so far in Jesus' name. Amen. All right, so Amphioxus. Gastrulation in a branchiostoma, I said, takes place in the presence of or occurs through invagination, involution, and what? Expansion. Now, expansion, of course, marks the last part of gastrulation, because that is where you have the embryo to increase, all right, in size. All right, take note of that. So gastrulation in Amphioxus, I'm not going to be saying much here because I've simultaneously explained gastrulation in Amphioxus by doing this. All right, now the only part I never mentioned, which I'm about to do, you have it to be called Chordamesoderm. Now, what is the importance of once a given cell invaginates? What is the hollow structure formed? I told you it is what? The acantharon. Now, in Chordamesoderm, that is anus and mouth. The Chordamesoderm in Amphioxus gives rise to what is called what? Notochord. Notochord in Amphioxus is what acts as what? Backbone in higher what? Chordates, like man. Vertebral column is to man. The notochord is what? Branchiostoma or Amphioxus. That is what you have it to be. Now, this same Chordamesoderm, on the roof of the acantharon, you have what? the mesoderm. All right, that is on the roof of the archeteron. You have what? The mesoderm. The mesoderm has the ability to actually give rise to what? Guts. All right, guts, gut. That is gut. Take note of that. So I said that when the blastopore produces mouth, all right, you call it what? Protostomes, anus, deuterostomes. Now we are going to be understanding this better while treating neurulation. So at this point, to call it a day. In my next video, I shall be dropping points, or my next video is going to be based on neurulation, and of course the third video will be on gastrulation in mammals, like gastrulation in amphibians. Okay, what I've just done is gastrulation in Amphioxus, and of course the three terms associated. You can actually add this fourth one, which is this is the third one, of course, and this is what the fourth one. Extension happens before what? Expansion. So at this point, we call it a day. Thanks for watching. Please endeavor to subscribe.